In this video, I am talking about decoding silicon. This is Caspia's vision at DAC, that is the Design Automation Conference, and this was in 2025. I'm going to be talking about specifically about hardware technology today, and specifically what we are looking at are the security requirements that Caspia is focused on at the DAC. And this is as of July 7th, 2025. This is an image showing the DAC. It says the Chips to Systems Conference. It shapes the next generation of electronics. So as you can see, Caspia, it's really focused on hardware technology in chips. So first of all, why hardware security matters in 2025. So it's becoming increasingly necessary in 2025 because there's more technology. There's more advanced AI and autonomous systems and advanced technology. And because of that, it is important to not just keep the software security well, but also the hardware security. That's also important. A few examples of this would be like silicon would need hardware security for it to prevent overheating. And overheating could contribute to burning. So to prevent burning, silicon would need hardware security. Another example would be to prevent silicon from various attacks. And those could be like liquids, like spills and computers and things like that. So hardware security is often overlooked, and it seems to be pretty important, generally speaking. And then here I'm talking about Caspia's focus at the DAC 2025. They talked about key security requirements for different key security systems. So Caspia's focus on security needs was prominent at the DAC 2025. And I'm going to talk about this from the standpoint of an electrical engineering viewpoint, with a focus on semiconductors. So, emphasis on multiple crucial areas as particularly enlightening. First off, the implementation of the ROT, root of trust, is becoming indispensable. This guarantees a basic level of hardware integrity upon which software can depend. This is indestructible DNA of your system. It's basically really necessary and really important. Secondly, the confidentiality and integrity of data, both during transmission and when stored within the chip, are also very essential. This incorporates sophisticated encryption and session memory designs integrated into the physical uh, design. And then ultimately, tamper detection and resistance are integrated into the. It's actually tamper detection and resistance that are integrated into the physical design. And this is what makes it exceptionally challenging for uh, malicious individuals to physically breach the hardware. Basically, it's hardware security. It makes it harder to breach the hardware security and hack the security. Next up, now here we're going to talk about some of the challenges involved in this. So the electrical challenges, and we're specifically talking about the electrical challenges involved in this from an electrical engineering viewpoint and perspective. So, these security requirements have quite some challenges. First of all, designing complex circuits that not only perform their primary functions efficiently, but they should also include other functions such as they should have cryptographic engines as well, and memory controllers, and they should have sensor networks for detection. And it's not just that, they have to do their function and have these other key components, but they have to all have this within tight power and area constraints. And that is quite a challenge. This is a complex task. And it requires innovation in many areas, from low power design methodologies to new materials and architectures at the transistor level. So, yeah, and this task involves a decent amount of circuit design, a great amount of physics, and a very little bit of cryptography altogether. So it's circuit design, physics, and some cryptography as well. It's a mix of all of those three things together. Now, why this matters and why it's useful for the chip industry. The emphasis on such hardware isn't isolated to electrical engineering. It carries significant consequences in various domains. So it's used basically all over the place. It's used in different areas and disciplines. Consider such AI inferencing on edge devices, the integrity of information gathered by Internet of Things, sensors in vital infrastructure, or, for example, the safety of autonomous vehicles depending on the corrupted processing, or the confidentiality of sensitive medical information. See, this stuff has like the hardware, technology, hardware, so, the hardware security has many applications in many different disciplines, and a few of these would be, as mentioned here, the medical industry, on sensitive medical information, or could be in sensors, Internet of Things sensors, vital infrastructure. Could be for inferencing on edge devices in that field. So yeah, for aspiring engineers, no matter if your main concentration is electrical engineering, or if it's computer science or biomedical engineering, it is important to grasp these core hardware security principles because, as mentioned before, they're used in a lot of different industries and disciplines. This is essentially an interdisciplinary challenge. It requires some teamwork as well. Now we'll talk about Caspia's role in the semiconductor industry landscape. So Caspia's focus on security at DAC 2025 shows that hardware security is quite important and is a fundamental requirement in designing chips. So Caspia in this DAC 2025, they're putting a strong emphasis on hardware security. That's pretty clear already. And they're saying that's basically pretty important, and that it's basically not necessarily as maybe important as software security, but pretty close, in terms of importance, and that there should be more emphasis put on hardware security. And what this shows is a shift where both hardware and software security are considered important and are both designed as a necessary part of the design process. And in my opinion, this trend is likely to accelerate due to the increasing new technologies and AI models. So, in conclusion, there's some information about just conclusion stuff. I find the process of how chips are designed and technology involved making these chips to be very interesting. And, what are your thoughts on the importance of the hardware security, or what other trends in the semiconductor industry are you following? Let me know in the comments below, and don't forget to like this video and subscribe. Thanks for watching, and I'll see you in the next video.